So what I've done is I've trimmed the width of it down by 1 inch on either side and welded those pieces underneath to reinforce the edge. And also at the front you can see a lot of weld where the pieces I cut off, I've welded those up underneath to thicken that front edge as well. So we don't get so much bounce when you hit stuff. It doesn't flex so much. And then drill the bottom table and just bolted it straight through the whole lot with 1/2 inch bolts. Go to the next one, please. Yeah, there's the detail of the wheels. They're literally just metal casters with bits of thread bar that I got. That's the cheap stuff that's supposed to be for hanging light fittings off. So I used it for as much as I could. And I've made all this. I cut the railroad ties up. I tried using a circular saw, one of the handheld ones, and the creosote in it just gummed the blade up something awful. So I took a chainsaw to it. That worked really well.
Okay.
And then go to the next one, please. Okay, that is the obviously I-beams are not very hard. So when you put pieces of metal on them and whack it with a big hammer, there's a good chance of denting it. And it won't harden up because it's not the right grade of steel. So I got in touch with Metal Supermarket down on Lovell Road and asked him for a piece of hardenable, heat-treatable steel. Basically, the piece he was using as a doorstop. And this is where the good part starts. He sold me that lump of 4140 heat chrome molybdenum steel for $60. Normal price for that, I was quoted 150. Also, when I went down to see him, me being a Royal Navy veteran and him having a lot of military history in his family, he was very, very helpful and offered us a chance to go and basically raid his offcuts rack at what works out at a really, really reasonable price. So once we get the blacksmithing shop set up, we'll probably go down and do that. But that piece is going to be welded on basically where it is. The bit that's hanging over the side there will get cut off. The bit hanging over the back end will stay there. And at the moment, I've drilled 4 holes in it where I'm going to make a hardy hole. For those of you who don't know, it's where you put the little static tools in. And yeah, that's a heat treatable lump of steel. So once it's all done and welded on, that's when you get the fun part. You get to build a big furnace around it and harden that off, and that will give us a surface that won't dent or bend, and will still be tough enough to take, hopefully, many years of me pounding on it and anybody else that needs it. There's one more slide. Yeah, that's it's a bit difficult to see, but that's just the marking out of the underside. So it's a 2-inch wide chunk that's going to get cut off the side, and maybe someday I'll show you what I made with that piece. So that's about it. I built my own forge. I've made a rounding hammer, and I'm building an anvil. As soon as we get the place set up, I'll bring it all down and make the tools to make stuff.
Hey, that's awesome. We do have a comment from Dee Dee. She's saying, what welding procedures are you going to use to attach the 4140 to the beam? Well,
you have to preheat the chrome moly steel needs to be preheated. So I'll run that up to probably about 400 degrees, and then I'll just straight MIG it on. I shall be drilling a series of holes in the face of the anvil body, and then I'll plug weld in the back, so that you've got weld all the way across the whole surface. You'll have weld all the way around, and then like half a dozen 1-inch holes where you've got weld inside, and you fill that hole up with weld from the underside, and that should secure it pretty thoroughly. And then once it's heat treated, of course, any stresses should be basically worked out, and hopefully I won't get any cracks.
Yeah, especially after you've been pounding on it a bit. Hopefully none of those welds will crack.
Well, I again, you always run a risk whenever you're welding dissimilar metals, and you've got what is basically a mild steel and a mid-carbon chrome moly alloy. So you always run into somewhere in between. When you weld the two together, somewhere in there you're going to get some weird sorts of alloys. One of the most prevalent ones for those, if you use an 18/8 stainless steel and weld it to mild steel, somewhere in the middle of that weld you're going to get a 914 steel. And 9/4 steel, it's just really brittle, and it always cracks. So, but I have seen other people where they've welded 4142 medium low carbon steels and got away with it. So I'm looking it up on YouTube. I'm checking around and seeing what other people have done, and working on those principles.
Well, other comments are that they want to see the hardening. I don't know if that's something you can videotape maybe, or take some pictures as you're doing that. And we've also got a comment that your project has been very well thought out.
Well, yeah, I mean, the heat treating it, it's, I'm going to say, I saw one guy who actually videoed the whole process. Obviously, sitting there watching it get hot is kind of tedious because it takes a couple of hours. But they had it all set up, and what they did and the way they did it was like, oh, that's a lot of bits that you didn't think about before. You go, oh, yeah. So, yeah, I intend to video it. I'm trying to get a YouTube channel set up to show some of this, the build of this, because I've kept video of it. So yeah, it's hopefully the videos will be out there soon once I figure out how to get YouTube to work. I'm not terribly tech savvy.
That's a downfall many of us have, so you're not alone. But welcome to Knox Makers, where we love to learn and teach each other as well. You've got a lot of people in here to help you. Just post questions on Mattermost. I'm sure someone will come to your aid. Well, thank you, Colin.
Thanks very much, guys. Appreciate it.
All right.
And thanks for the comments. That's always good to get support.
You have lots of it here.
Thank you.
You're welcome. Oh, I guess we missed one.
Oh, did we? Oh, not to worry. That was just a close-up of where the hole is going to go into the square hole for the hardy hole.
Okay.
Not a big deal.
Okay. Well, do post that link for your YouTube channel when you get it up and running.
I will. I'll get that up there, and we'll have. I'm not even sure what I'm going to call it yet. So any suggestions for a YouTube channel will be greatly appreciated. The funnier, the better.
Oh. Let's go ahead before I say something that I probably shouldn't. With the PG rating we have, we're trying to maintain. We've got Isaac here with some sound deafening. Oh, wait. That was last week. You were talking about your stereo. That sound deadening. What you got for us, Isaac?
Well, this is a sort of a related project to share. If you would bring up the first slide, please. The subwoofer project that I shared with y'all, I completed that and I tuned my stereo, and my girlfriend was sufficiently impressed that she decreed it was time to rebuild her car stereo. So that is the project that I'm working on now. And so we took a couple of days to decide, make a plan and get parts ordered and all that jazz. And the first order of business is always sound deadening. And I thought that was maybe a slightly weird thing to do. And so maybe somebody would find the process interesting. A vehicle is a very challenging audio environment if you want to have good sound quality. There's a lot of background noise that comes from, the engine, the transmission, from the wind and from the road transmitted through the tires and all that sort of thing. Our brains do a relatively good job of blocking some of that out of our consciousness, but it's present and it's something that has to be overcome by the car stereo to get, a nice quality sound. So if you can deaden some of that out, then it's like you've upgraded your stereo for free. And two, if you put a powerful stereo in, that's going to tend to make your car make objectionable noise. I mean, you've all encountered that at some point. And that's just embarrassing. So you don't want to do that. You want to deaden those sounds. So this slide here that you're looking at, this is an image of the type of sound deadening material that we're using, which is something like 5 or 6 millimeter thick layer of butyl rubber, which is the black stuff you see there. It's very stretchy and sticky and self-adhesive. And it's got a backing material on it that's something akin to like a thick tin foil. This particular product that we're using has got a texture on the tinfoil side because when you apply it to the sheet metal, you want to sort of burnish it down to make sure that it has a good, strong seal. And it's basically when you destroy the pattern that it comes with, you know that you've thoroughly burnished the whole surface. And so if you would advance the slide, please. This is an image of the inside passenger door with the trim removed. So this is what's behind the door panel that you ordinarily interact with. And so you can see a fair amount of sheet metal there, painted the white body color. And then there's that sort of a creamy colored, strange shaped seal, and then a fluffy business in the middle. So that creamy colored foam seal is connecting a flexible plastic to the body of the door. It's sealing a big open cavity to make it sort of airtight. That's often referred to as a vapor barrier. And my understanding is it's to try and keep moisture that slides in from the window area from getting into the main cabin. And then the fluffy business there is intended to absorb some of the noise. So this is where you start. And so if you would advance the slide, please, you'll see I've torn off the vapor barrier and removed all the remainder of that seal. And so now it's just, you can just see the sheet metal there. And through those openings, you can see the outside skin of the vehicle. And then those horizontal, they're tubes actually, those are like crash bars or beams. So if there were a side impact, that would absorb some of that, right? And so that outside skin of the vehicle is like the membrane of a drum. It does not object to vibrating. And so I want to sound deaden that outside skin. I also want to try to sound deaden the inside skin and seal everything to the air insofar as possible, because the speaker would like to have an enclosed airspace behind it. And so here, this is not terribly visual, but you're looking inside the door panel. And although the example of material that I showed you, although that example was silver, the foil part, the type that we actually bought has a black foil. And the advantage of the black foil is that if you use it in areas that are covered with the interior trim, where there are seams between the trim, you might see the shiny silver stuff. So we bought the black instead so that it will tend to hide itself if it would be exposed otherwise. It would never be exposed here, but in other parts of the car. So here I have applied the sound deadening to the outside surface of the vehicle. And if you would advance the slide, please, Sue. The next step is I need to close off those openings. Now, the reason why those exist, I'm sure it's something to do with the manufacturing, but it also gives you access to get inside the door to mess around with the wiring or to fix like the power window if something went wrong, which in my experience is rarely necessary, but you don't want to rule that out if some sort of a repair were needful. So what I've done is just take some relatively thin metal and just sort of made these little bridges across that space and riveted it down. And that's going to give me something to anchor my sound deadening and sealing material to, and give it a little bit more structure without precluding access to the interior of the door. If you would advance again, please, then you'll see the interior now of the door surface has been sealed and sound deadened pretty thoroughly. In the bottom left-hand corner, that of course is the factory speaker. This is the alleged premium sound system, and it is, I mean, it's not terrible, but it ain't great. But I've sort of avoided getting any sound deadening in that area so as to ensure that the factory speaker can continue to mate with the door for now. Part of this, I mean, this is going to take me a couple of weeks to get all the way through this stereo upgrade probably. And I want to make sure the car remains drivable and also that the stereo works for as much of that as possible, because the music is important or we wouldn't be going to all this trouble. So whenever I actually put the new speaker on, that's when I'll finish the sound deadening job. And there's some other things to do there too. So if you strike the door panel, ordinarily you'll get kind of a ringing sound, which is demonstrating the resonance and the vibration that we're trying to kill. Once it gets to this stage, if you rap on it, it's fairly acoustically dead. And so I feel like that this is a good job. It's not attractive, but it's never going to be. It's going to sound pretty. And if you would advance the slide once more, please, what you'll see is the inside of the door skin. This is the piece that was removed there, of course. This is not the side you usually touch, so you can see how this thing is manufactured. It's made of a surprising number of different pieces and different materials, including styrofoams, and it is also got the potential to rattle and make noise once you put a decently powered speaker in there. And so I want to deaden that as well. Something that I was asked on the chat server was, you know, why are you giving such a ridiculous amount of power to this stereo? You know, are you trying to like send yourself to the moon or remove your head? One of the things that plays into this is that a factory stereo is designed to be as cheap as possible. And so the speakers are electrically very efficient. They require very little power to make a lot of racket, but they do not reproduce sound with very much fidelity, and they're not able to cover as much of the audio spectrum as you'd like. So when you have a nicely engineered speaker, one that can cover, you know, quite a broad audio spectrum and do so with high fidelity and high volume if you want, that type of speaker requires considerably more power because it's less efficient. So we're going to throw a lot of juice at this thing just to make it sound nice. So in this image, then, this is the starting point. For the door skin. And what I've done is just gone back in and sound deadened that as well. My focus was particularly in this area. This is where the speaker grill is, and this is where most of the sound energy will be. So I tried to get really good coverage in this area and much less so throughout the rest of the door skin. It is, I see a remark here in the chat, it is a lot of work, and I know that it is borderline crazy town, but it sounds so pretty when you go through this process. I just find it really, really satisfying. I really like music, and it is satisfying to do nice work. So it is crazy town, no doubt. So this panel is now deadened. The whole door is now deadened to my satisfaction. So we're ready to move on to other parts of the process. We've actually completed the sound deadening, and we'll be doing other bits of the upgrade soon. So that is what I brought to show you this week.
I met up with Charles this weekend, and he was on his way to a car show and was showing me his stereo speaker or his stereo system in the back of his trunk. Very impressive. So it looks like up next, if you can hear me, is Ray. Are you out there, Ray?
I'm right here, Sue.
Yeah, right.
Yeah, go ahead to the first slide if you don't mind. We have been busy in the electronics area trying to solve the current world pandemic. We figure the boys at UT are playing with their toys, but we were going to get to some real work over here in our neck of the woods. Following a couple slides, this is what you get when someone who isn't that funny tries to be funny and isn't really good at delivering humor, and you get forced to sit through it as a captive audience. So I'll just apologize in advance if you don't find it humorous, but maybe a couple of you will. And here, of course, you got a couple images, which you've probably all seen something like this in the news. Next slide, Sue. We did all kinds of studies on our work here. We've made a little electronic circuit that we have determined has been so far 100% successful in preventing coronavirus in all of our subjects for all time that we've studied and all the geographies. And please don't read the fine print. I've been advised to make the footnotes even smaller, so it's even harder to read. Go ahead to the next slide, Sue.
Results may vary.
Yeah, results may vary. But in all seriousness, what we've got here is this is just a little custom circuit board that I made up to do a socially distanced build class. It's tough to do a lot of classes that we've traditionally done around here when we can't get together in person. I kind of grabbed Isaac offline and we chatted a little bit to say, hey, what do we think about trying to do a build class or two out of the electronics area over this big blue button software, and we think we've got a way to do it. So I did this little board. It's kind of like a copy of a coronavirus thing. It's very simple. It's like some other intro to solder classes or just build classes we've done. You power it up with a little USB port power. There's a little power switch on there, and the lights blink, and that's it. So that's what the deal is. Go up to the next slide. You can see the back of it. You see up top a little USB micro jack and a power switch to turn it off and on. I originally had a video to include that shows it blinking, but videos don't work over software like this very well. So instead, I do have one more slide that just shows at least a couple lights illuminated. So if you could go to the last slide.
Ooh.
There you go. Yeah. So it's cool. They just kind of blink semi-randomly. So this, we have a class on the calendar to actually build this. And we anticipate having a couple of feeds, one feed that shows like the headshot of, I think I've got Isaac convinced. I think Isaac is convinced to do it, of Isaac and his pretty face talking. And then another video stream of the actual building. So we'll actually walk through and demonstrate how to solder and how to build this thing. And then you'll have it to take off and show off to your friends, tell lies, tell stories, whatever you want. And the way, so the way we're trying to do this is you sign up on the class like you normally would. You just get a ticket for it, and then I'll email each person as the tickets are purchased for their address, and I'll just mail the kit to them. So they'll get a kit in the mail. They'll have to have their own solder iron, little nippers, so they'll have to have their own stuff. They won't be able to use the spaces tools like we normally do, since we'll all be in our own houses. But we've got a little guide on some things we suggest for maybe some inexpensive solder irons, some things like that they could use, or they can look at other things on the internet as they choose. And then we're doing the actual build online on the 5th, August 5th. We actually have the ability, apparently, on this big blue button, you can have a main presentation like we have here, and then you could actually kick people over into like a side channel or a side room. So if someone's having a challenge building it, they can jump over to a side room. So if Isaac's running the class, I can be in a side room helping people, trying to identify problems, help fix things as they go along. So, so that's the plan. On this class, it's worth noting that registration is being cut off a week before the class starts because we need time to actually mail the kits to people. So
Good point.
yeah, so hopefully that's enough time, but that's unusual. Probably if you thought for a moment that would come to mind, but it might also be easy. We often wait till the last minute to sign up, based on our schedule, that kind of thing, which wouldn't work here. So we're going to try this. I hope it goes well. I hope we get some signups and people enjoy it. And if so, we'll put some more on the calendar like this, and hopefully keep things going over the next weeks, months, hopefully not years, until we can get together and do this in person again.
Yeah,
and that's it. So,
yeah.
Yeah.
Nice little project, Ray. Thank you.
Hey, thank you, and hope we get some signups. Hope you guys enjoy it. Hope folks who do it have a good time.
Yeah, and again, that's the evening of August 5th. And if I remember, it's like 7:30-ish. So hopefully that fits into everybody's schedule.
Yeah, 7 p.m. I put 7 to 8:30 in there. This is probably like less than a 1 hour class normally if we did it in person, but just anticipating it might take a little longer to help people since we can't walk around easily, see things and help them. So we allotted a little extra time on this one.
Well, I see from the chat that we have people who are missing soldering with Isaac. Yeah, I for one would probably be in that little side room trying to get help. One night when we had a lot of Radio Shack little kits, and you could purchase and solder. So I tried my hand at soldering for the first time ever. And Isaac did compliment me on my technique, because I soldered from the opposite side that you normally do. So the front side instead of the back side.
Of course. But it could work.
Hey, as far as, yeah, okay. So
Yeah, you could solder that side.
that's what we're all about, learning and sharing and
Absolutely.
getting it done. Well, thank
All
you,
right, well,
Ray.
thanks, Sue. Appreciate it.
Next up, is John. Oh, John Dale's here. He was giving me a bad time earlier,
What was I doing?
telling me I went offline.
Oh, I'm sorry.
Oh, no, that's okay.
Yeah, if you'll go ahead to the first slide. Can you zoom out, or is that just how it is? Oh, there we go. So, yeah, so I have a lot of firewood, a lot of wood. I chop a lot of wood, and I have a few places to put it, but I needed more. And so, of course, my first instinct was to go into Inkscape and draw one up to build. And so this is kind of it, just so I could put together how much wood I would need to buy. I was going to do a metal roof, and so I just sort of drew it up in Inkscape, and this is what I came up with. So if you go to the next one, that helped me calculate what to get. I just went to local big box store, picked up my stuff. If you go to the next one. And then I just started building it. You can see I tried to level the bottoms. I think if I were to do it again, I wouldn't build up. You could see I built up and put around some paver sand around the bottoms. And of course, when it rains or whatever, it's pushing that stuff out. I think what I would have said that is got longer boards and then just cut them off to the right size. And gotten a better solid ground, but this has worked okay. I've ended up putting gravel around that so it wouldn't wash away. And so I just built the sides first, and then I moved on. If you went to the next one, and then I just started putting. I connected them together, and then started just doing sides. I really wanted a lot of airflow, and so you can notice everywhere that I connected, I left spaces in between it. Wanted a lot of airflow to let the wood dry. If you go to the next one. And there it is, built, and my daughter's standing in it. And then if you go to the next one. And there it is full. I made it too deep for the size wood that I chop. I wish that I would have made it a little less steep. That middle, if you notice, the wood's just on 2 of the bottom. There's 3 boards across the bottom, and it's only on 2 of them. Yeah, my daughter's still in there in the back somewhere. So that middle board really started bending down with the weight, and so I put a brick underneath it. But I wish I would have designed it a little thinner so that I could have made sturdier boards on the bottom. So maybe the next one. But next one. Yeah, so on the back, you notice I made the metal go up, protrude out the back quite a bit so that I could just put some screws in the back and store my axes there just to keep them dry. It's actually kept them really dry. I was really afraid that they would get wet and rusty there, but they've held up pretty well under there, so it's been good.
Nice.
Right. And then the next one. And as you can see, it is now full, and I still, of course, on my property, I get tons of wood, and I still have a lot of wood to process, and so it's time to build another one that's bigger and better. Yeah, those There is one Fisker's in there, and there's a huge one. That one holds maybe, I wouldn't say, wouldn't say a full quart, but pretty close, pretty close. Yeah, I think that's it for me. Time to build
So
another
are you
one.
using the wood to heat the house, or
Yeah,
are
I
you just
have
fire outside?
I have a wood fireplace. Yeah, I heat it in the
Okay.
winter with that. I have about 4 places about that size full of wood currently, and I need to build more. So I probably go through about 2 of them in a winter. So,
And which way does the rain, is the rain typically coming from the other direction? And
but if you notice there, it's under quite a bit of tree cover, so it really doesn't get a lot of rain right there. The wood doesn't really get wet. The rain doesn't come in that way, so I'm pretty lucky there. I didn't plan it that way. It just worked out that way. So,
Are you like a squirrel in that you forget where you've built woodsheds and
yes,
stash of wood?
I probably have a few woodsheds. I don't know where they are right now. But... and daughters, yeah, I probably have a few of those somewhere. Yeah.
Well, thank you, John Dell. That's pretty inventive. I like it.
All right.
So Gabe, it looks like you're going to give us a dress project.
Hey, this is working.
I can hear you.
Sweet. All right, I'm here.
All right.
Okay. Let's go to the first slide.
Sure thing.
All right, so wow. So ever since I moved out, my parents, when I was, I guess 17 or 16, I don't remember. I've never had a dresser, so I always just had my clothes in a bunch of plastic bins, and so I decided to change it up a little bit and build myself a dresser. So what you see here is like sort of the beginning of my project. I got a bunch of there's a lot of cypress that grows that's native to Florida in Gainesville where I am. It grows out of the swamp. So there's lots of it here, and so what you see there are some cypress boards that I bought from a sawyer. So they're all from the same tree, and the grains all match. So it's nice that way. And so that's the beginning of the sort of the first pieces that I started gluing together. Next slide, please. So it's a really long glue up, and recently I read this book called The Glue Book, which pretty much goes over every glue and all its properties, and every glue's properties, and like when to use what glue. And once you read something, you can't unread it. So it's like you got to use the
Use the knowledge, right?
yeah, you got to use the knowledge once you have it. So the glue up, this glue up took a long time. It took me like 3 hours to glue the whole thing together. And what you see there is liquid high glue, which has a really long open time. And if you take too long, you can reheat it back up and it'll soften up, and you can keep doing a glue up. Whereas if you use something like Titebond, which most woodworkers use, or any other kind of PVA glue, they usually have 5 to 15 minute window of when you got to put the clamps on your piece. So that's just what I used. And there you see some of the joinery. I used a domino mortiser, which is a pretty popular tool now, and it cuts mortises really quickly. Now I'm like a machine person now. I used to do everything by hand, but yeah. So those are machine cut mortises. Next slide, please. So you can see these floating tendons as I'm putting two pieces together. I mitered each board on the end so that it kind of looks like a continuous grain instead of like having. You'll see in the next couple slides. Okay, next slide, please. So to clamp these miter joints together, I hot glued some cawls that were cut at 45, because otherwise it would be hard. It's hard to put a clamp on that will like pull in that direction. If I was to do it again, I wouldn't use hot glue because I thought I could just take a heat gun and reheat the hot glue to take the cawls off, but I ended up having to kind of just rip them off. And that ripped out some of the wood with it. I was able to like fix most of it, but I think next time if I was to do it, I would use double-sided tape and then have a clamp on each side that kind of holds the board, holds the cawl down onto the board, so there's more pressure, and then do the 45 clamps. If that makes any sense. Next slide, please. So it's a monster of clamps. It's like, I don't know how many clamps I used. I just kept clamping and clamping and clamping. There's probably 20 to 30 clamps there. So now you can see the top boards and the top and bottom boards are in too. Next slide. Here's another shot from the backside. So after I clamped it together, it was a little bit out of square. I think by like maybe like 1/3 of an inch, which was enough to, if I had left it 1/3 of an inch out of square, it would be enough to throw off my drawers. So you can see that diagonal clamp there, just kind of like, it sort of just like muscles it into square. And I was able to get it down to about like an 1/8 to 1/16 inch out of square. Next slide, please. So that first board you saw was the middle board, kind of gives the dresser most of the strength. And for that, I did do a lot of a lot of hand work, where I cut these through mortises with they're wedged so that like, I'm not perfect when I'm cutting by hand, but if I stick a wedge in there, it kind of spreads the wood open and fills up any gaps. And it also gives it more clamping strength. So next slide, please. Here are the back slats going in. So each of these boards are shiplapped. They have a little, I don't know how to say it. It's a rabbet on each end, so that over the seasons, the like when the humidity in the air changes, the wood will expand and contract.
Right.
Yeah, and then so there's like overlap between each board.
You don't see the clothes inside, if you will.
Yeah. Next slide, please. Oh yeah, sorry for all the specific joinery and woodworking terms. All right, so this is it all closed up. Next slide, please. So I chose to use these drawer slides that were made by Bloom, which is I think an Austrian company. There's so many different options for drawer slides, and you can even use wooden drawer slides, obviously. But after having worked at a cabinet shop and having seen, at the shop I worked at, we experimented with different drawer slides from different companies, and the Bloom ones never fail, and so those are the ones I chose. And so in this, I don't think I have a good picture of it, but I have 3 main drawers, and you see them later. and within one of the drawers there's a hidden drawer, and instead of buying a drawer box, I just cut my own out. And like this is a dovetail. This will turn into a dovetail drawer box, and like to anyone that hasn't hand cut dovetails before and that want to in woodworking, I would just say like just do it. It's like once you try it and it's not great the first time, but it's you just put some glue on it and it still sticks together, and it'll probably last way longer than you'll live. And then the next time you do it better, and like this is only my maybe like 9th time trying to do hand cut dovetailing, and it turned out like really great. It was almost perfect. So have no fear in woodworking. Just like don't cut your fingers off, but just if you have an idea, just try it.
Yeah,
just
sometimes
practice. It's not that hard.
and practice makes perfect. The first couple
Yeah.
that I made were absolutely horrible. Yeah, no.
All right, so next slide, please. So this is the main drawer boxes. So the first box I showed was a hidden box, but the main boxes are this line of drawers called Legra boxes that Bloom makes. There's a lot of detail going into different choices for drawers. You can order pre-made maple drawers. They're really nice. I just chose this because I didn't think about the drawer slides when I started the dresser, and it was in between two different drawer sizes. So I made the dresser 20-inch deep, but it ended up being 1/8 of an inch too short for a 21-inch drawer slide. So then the next slide down, and then the next size down was 18-inch, so I would be losing about 3 inches of drawer space. But this line of drawer slides come in small increments, so it made it an easy choice for me. Next slide, please. So here I'm installing the drawer slides. And the top here is sort of an empty space where you can put things like pictures or whatever you want. I got this idea after going to a museum. I used to not really care for going to museums, but now that I've been crafting, every time I go to museums, I get new ideas. It's like so refreshing and inspirational. There was this one exhibit I went to. It was a furniture exhibit by an American woodworker, George Nakashima, and he made a dresser with this opening on top where you can put things. So that's where I got the idea to do this dresser. Next slide, please. And then so inside this opening, I put a little shelf in, but it was sort of an afterthought, so I didn't cut, a slot to put that shelf in there. So it ended up being a lot of work. I guess the lesson is just plan your projects out better next time. So I had to like drill little holes and chisel out the dresser, with it standing up, which is not the best way to do it, but it worked out. Next slide, please. Oh, okay. So it's not a Gabe Tong project if there are no side quests. So here is my side quest. I wanted to make a little stand for the dresser to stand on, and I wanted rounded legs, but I didn't have a lathe, so I decided to make a lathe using a power drill, which there are tons of plans online. I looked at one person's plan and like modified it a little bit. So So you can see the lathe there. I have more pictures of the lathe a little bit later. And then I made the turning tools too. Just Baltic birch. I made the handles of Baltic birch, and I bought some key stock, which is like really cheap. And then some made in China carbide tips, and they worked out just fine. For what I need to do. It's not a super smooth finished surface using these tips, but it works. And the first time I turned anything was at Knox Makers. So that kind of like helped me get over the hurdle of like, oh, I can do this. I've done it before. Next slide, please. This is just a close up of the tips. Next slide, please. So here's the whole lathe. There's the drill on one end, and then there's a headstock, which I made out of a bicycle axle. Like I just knocked the axle out of the bicycle and took the bearings too, and then made a little mount for it. And then there's a point center tailstock. Just pretty like primitive as far as electric lathes go. Next slide, please. There's just more. This is the tailstock. Next slide. And the close-up of the headstock. Next slide, please. Just another view. Okay, next slide. All right. So back to the main project. Remember I was talking about putting a little shelf in. I decided to put some drawers in too. So here you can see 2 drawers that I made. Well, at least I made the drawer fronts. So the wood here is sweet gum, and the drawer pulls are made from live oak, which they're both 2 other native trees and around where I live. Next slide, please. Oh, and those little cars on top are sort of they were like the first toys I had when I was a kid that I had to like put together. So that was like the genesis of like putting stuff together. And I had like about a dozen of them that I've been lugging around. I was born in Hong Kong, and I had those when I was in Hong Kong, and I lugged them around all the way here, moved to like different states and everything. So I tossed all of them except for those 2. All right, next slide, please. So there's the finished dresser. You notice I book matched. So one really nice thing about knowing a sawyer, there's someone that loves sawing wood, is that I can ask him to. I ask my sawyer to make sure he keeps the wood he saws in flitches, so that I can buy pieces not just from the same tree, but cut from the same log. They're right next to each other, so that when you build a piece like this, you can have matched boards. Both the top drawers are matched, and then the bottom drawers are matched. Next slide, please. Oh, that's it. That's it.
I was
and
getting
the
mesmerized.
stand were the little legs that I turned. You can see on the bottom the little circular legs on the bottom. Okay, that's it.
Yeah, I'm mesmerized.
Oh yeah.
Wood pattern.
Thank you.
And
It is a dial indicator. I haven't figured out what I want to do with it yet. The dial indicator. But and is there any other questions up there? I think that
there
was
was
it.
a comment further back that dovetails are the best way to go for drawers. They'll last
Oh
forever.
yeah, for sure. All right.
All right, Paul, you have some musical entertainment for us, maybe with a keyboard.
Not that kind of keyboard.
Oh.
Oh.
Right now, what kind of keyboard do we have?
The kind you type on, but
Ooh,
it's not.
okay.
It's not the whole keyboard. It's just the number portion of the keyboard, like the number pad. So 2 years ago, give or take, I decided I wanted a new keyboard, and I started sourcing parts for it. And they had some keycaps on Massdrop for, they were going to be being made, and well, it took them 2 years to get them made. So I had plenty of time to like plan, but I procrastinated and didn't. And anyway, I ended up buying a keyboard that did not come with the number pad portion of it. The numbers on the far right side.
Right, yeah.
Yeah. So and I'm like, all right, I can make do without it, but I kind of use it a lot in programming and my job and whatnot. So I found myself missing it after a few days. So I decided I'll just make one. How hard could it be? Basic keyboard construction is you have a plate where or at least for mechanical keyboards, you have a plate with the key switches go into, and then that kind of goes on a circuit board, and then on top of the switches are the little caps, the key caps with the letters and the legends on them, and then that kind of fits into a box, a case. There's all sorts of online tools for making these things. I found a website that makes your plates for you and generates a drawing. So I plug that in, and that's what's on that slide there. As I said, I want a layout of this many keys oriented like this, and it generated that, and I took it and imported it into Fusion. And you can go to the next slide. Oh, these are out of order. Okay. Oh, that's a little bit further along. Kind of fast forward a little bit. Next. Oh, there's the last. Okay, so that's the key switch and the keycap, and then next slide. Okay, so that's the plate after I put it into Fusion and kind of made it thicker so the key switches would fit into it. And then I decided I needed something to put the wires on for the switches to send electricity through. So I kind of made a fake printed circuit board, which is basically just the whole pattern for the switches. If you go to the next slide, maybe that'll be it. I don't know. Yep, there we go. So the switches go into the plate, and then the plate goes onto the PCB thing there, and then I soldered wires together. If you go to the next slide.
Oh, I thought you were going to have me go back to the other one with the wires.
No, so that's how it all goes together right there. The switches go into the plate, into the PCB, and they're all spaced adequately. And then go to the next one. And then that's how it kind of looks with the case part on the bottom to bring it up to an angle. So I thought, so apparently I was kind of concerned about the wiring on these, but they're not very difficult to wire. You just need a diode per switch. And then you run everything to a microcontroller and load some firmware. And there's like tons of pre-made firmwares out there that you can use. Next slide, maybe. Okay, so that's it with all the switches mounted into the printed parts that I 3D printed. I could have easily used the laser cutter for a lot of it, but I didn't feel like driving down to the shop when I could just print it. Next, okay, so that is the electrical schematic for the switches. So each switch has a row and a column. So it's just a grid. So you have a column 0, 1, 2, and 3, and then row 0, 1, 2, 3, 4, whatever. And then you just put a diode on each switch to keep, what happens is it's called ghosting. If you press 2 switches on the same row at the same time, it could trigger a false positive. So you put the diodes on there to keep that from happening. The way keyboards work is internally, they have, they're all wired up. Each one of those rows and columns is wired up to just a pin on a controller chip, and it goes through very fast, column 1, 2, 3, 4, and then every time it goes to a column, it looks at each row. It goes row 1, 2, 3, 4, 5, 6, 7, 8, and it just keeps scanning through all of those. And then when it picks up that the rows and columns are, there's a completed circuit there, it goes, oh, that must be key number 5. So it does that several hundred times a second, and just keeps doing that all day long. So your keyboard is sitting there scanning everything every time it's plugged in. Next slide. So I did that. I wired the rows and columns together with little diodes and ran all the wires up to the thing. And now we got to go in reverse. keep going. Okay, stop. So I used I needed a microcontroller to wire it all into. The Arduino Pro Micro is made by SparkFun, and there's tons of clones out there. It uses an Atmega 32U4. I really like this chip because it has built-in USB HID, and HID is human interface device. So anytime you plug it into any computer made within like the last 15 years that has a USB port, it typically recognizes it as, hey, this is a keyboard, so you don't need any special drivers or anything to run it. That's built into the chip, and there's tons of firmware out there designed for the 32U4. So all I had to do was just wire the wires into it and load the firmware into like Arduino IDE and specify the correct pin mappings for it, which was just putting numbers in there. And that's, if you want to go back the other way, there we go. So that was my QMK firmware mapping. So I just put all my, this is what I want the keys to do. And then on another thing. So for IO, this is Billy's question, for like a number pad, a 32U4 is fine. For most of your like 60% or 75% keyboards, without the number pad on there, 32U4 is fine. Most of the SparkFuns, I think they have maybe 20 pins. Don't quote me on that one, but it's not quite enough to get a full keyboard. To get a full keyboard, you probably want to use like an AT90 USB 1280, whatever. I think it's the Teensy 2.2. It's basically the same line of chip as the one I'm using, but it has like 30 extra pins on it. I've used that one for another keyboard rebuild project in the past. It's just got, you basically need one pin per row and one pin per column. So if you look at a keyboard and count across how many rows you have, and then go down how many columns you have across for the keys, then you need a controller with that many IO pins to do it, basically. So once I wired everything up and flashed the firmware, I snapped the keycaps on and go forward one slide maybe. There's my completed number pad. I can now enter numbers.
And press enter.
And press enter. Big red enter button.
Yes.
It actually works.
Like you even have a volume control on there.
Yeah, I decided, like the standard number pad, it stops at the number lock and these keys right here. And it's my other, like the keyboard I bought is this giant hunk of aluminum with the PCB and everything in it, but it's lacking a lot of keys that I typically use, but they take up a lot of space on my desk. And I figured, well, I can probably condense that a little bit and split the number pad off so I can kind of shove it out of the way for things I don't use as much, like the mute volume. And this is just a little macro thing I can set to do whatever. I've got it set to open up the calculator. So I hit the cat and it opens up the calculator. That's the cat from Kiki's Delivery Service. It's a Gigi, yes, it's a Miyazaki anime from some years back. So that's my keyboard.
Behind the keyboard. I'm seeing how now the little breadcrumbs and potato chip particles mess with the keyboard.
Oh yes, the GG key loads up the calculator. It's just, I mean, it can do anything I want it to, but I've got it set to do the calculator. And then the other keycaps I got on here, I got the Space Invader keycap. Can't go wrong with Space Invader. You get these keycap sets, and they have more keycaps than you could really need in different sizes and shapes, and they've got a lot of extras that you can put on there and play with. This is actually a prototype. I'm going to have a circuit board made with the 32U4 already on there, and I'm thinking about swapping Gigi out for a rotary encoder that I can control the volume with instead of the up and down buttons, and then have encoders most of the time have like a button push, and I can have that do mute, and that'll give me 3 extra macro buttons plus the encoder knob. And then it'll eventually maybe If I can find someone to do it, I will get it CNC'd to match the main keyboard out of aluminum, because I'm doing all the CAD work to where it should translate to a CNC. But right now it's mostly just 3D printed stuff because that's quick and easy.
And it's a great way to iron out the measurements.
Yeah, yeah. Well, yeah, a lot of times when I see these keyboards, the gap between, like you're talking about the food particles, the gap between the side of the keyboard, the keycap, and the side of the case is really wide, and it just accumulates crap. So you get a tighter spacing, it's like less likely to pick up cat hair and everything else. So
very nice, Paul. Thank you so much. Very nice.
thank you.
All right, just a quick review until we get to announcements. And on announcements tonight, we have building. Great work has been done. The last I checked over on the building channel is that they're trying to get together a work party this weekend. If you're interested, please join up. They're trying to decide whether it be Saturday or Sunday. They're down to just 5% of the building left to do. And it was a huge milestone this past weekend that it is fully enclosed now. And it's a great job, you guys. And I know working in the heat has not been easy. And yet you're out there still plucking away at it. Yeah, it looks amazing. We've got some new signs up for the new rules that are out. Masks are mandatory now in the shop. I left some more on the table. If you don't have one, they're there for you so you can use them. Also, please use the hand sanitizers that are on the table and the wipes. If you can't get into the bathroom to wash your hands, at least use the hand sanitizer. And always remember that the equipment that you're touching may be infected. So do be cautious, do be careful. We want everybody to be safe, and we don't want to be identified as the place for any infections. So be safe, please. Authorization classes these days, they're a little bit different. Some of them are virtual, some of them are one-on-one. We've got them going in metalworking, woodworking, machining. You can reach out to the area in Mattermost, or for, I believe that metalworking, you can reach out to Dee Dee. You want to reach out to Brian for woodworking and Billy for machining. You can send them a private message and see what's up. We have a new email address for those who are watching this on Facebook and you have something you want to share, or those of you who aren't members, you can send your presentations, the things you've made, to sas@knoxmakers.org. Again, this is for the public. The rest of you, you know the routine. You can send to John Dale or Tracy. So again, SAS, show and share @knoxmakers.org. That's the end of our presentation tonight.